Good morning! Okay guys, good. I'm glad you had a good quiz, I hope. I hope to get that to you as soon as possible. But here's a lesson for today. I thought I would just finish like this because I know that you guys will be finishing your quizzes at different times, okay? Alright, so let's do this. So 6.3, how do you combine radical expressions? How do you add, subtract, multiply, or divide? How do you simplify them? What are conjugates? So a couple of questions that we're going to be able to answer after this lesson. And it's basically like combining like terms with radicals, okay? So let's get through this. So here's part one, combining radical expressions. So I want you to look at this. See if you can actually combine this expression, okay? So can you actually combine this? All of these terms, 1, 2, and 3, right? Can you combine all these terms? Well, they do have all radicals of 2. But yes, this one has an nth root of q, 3, so you can only combine these two guys here. They're the likey terms, right? Only if they have the same indices, exactly. So this one has a 2, this one has a 2, this one has a 3. So you know that you can only combine these two, okay? So when you actually combine them, what do you get? It's 5 root 2 minus 4 root 2, right? And you leave that guy alone. So you should get root 2 plus cubic root of 2 is your answer. Don't forget the index when you're writing your solution, okay? Now you try. Can you simplify these two for me? Okay? Sorry if you can't see that very well. I'll just rewrite this. It's x. Try these. Try these on your own right now. And then check your answers with me. Have you tried it? Stop the video. Alright. So here, no likey terms. No likey terms. Cannot simplify, right? This is it. This is the most simplified. How about here? Well, do they have the same radicals inside? Radicands? Yes. And the same index? Yes. Therefore, you should have gotten 9 cubic root of x squared. This is sort of like the variable, huh? And this is like the coefficient. Alright, that's it for that. Alright, let's try a couple more, okay? So why don't you guys try why don't you try right now, number 22. Here you go. Can you combine these? Can you simplify these? I don't know. Can you? Alright, so you guys, check this out. Same index. Right now, well, let's simplify first, right? The first step is to simplify the radicands. So you know, but you got to think in fourth roots, okay? Think fourth roots. Think fourth roots. What's the biggest fourth root that goes into 32? Now we're a little better with this, right? So it's 16 times 2. Because 16 is 2 to the fourth, right? Because 16 equals 2 to the fourth. Plus, how about 48? What's the biggest perfect fourth that goes into 48? Well, it's again 16 times 3 though. Okay? So now let's actually simplify this first, okay? 4 to the 16 is 2 root 2 with a 4 here. Okay? How about here? 4 to the 16 is 2 fourth root of 3. Now, can we combine these? No. So we've simplified, but that's the furthest we can go. That's a solution, yeah? We can't simplify anymore because the roots are different. But we've simplified them. Alright? Now, how about here? Now we're actually multiplying, huh? So I guess you guys like to call it FOIL. I don't really like FOIL. I just like to call it distributive property, okay? So let's do this, okay? So we do a times this guy here. 2 times this guy. We're distributing, okay? Root 7 times this guy, this guy. Let's write this out. 2 times 3 root 7 is 6 root 7. I'm sorry, I don't know why I did that one first. 2 times 1, let's go back. 2 plus, okay? Now plus, 1 times root 7 is just root 7, plus 3 times root 7 times root 7. But I'm going to write this like this. 3 root 7 times root 7, right? Oh, I'm sorry, root 7. But you guys, just know that you can actually just, you don't have to show me that step if you don't want to. Simplify again. So I got 2 plus 6 root 7. I'm just going to write this all out before I simplify anymore. 3, but it's 3 times root 7 times root 7. What's root 7 times root 7? That's just 7, so it's 21. Because this guy, root 7 times root 7 is going to just be 7. Okay, guys? Remember that? Because it's root 49. And let's simplify. These are the actual numbers here. So it's 23, constant, right? And this guy is 6 root 7 plus. Don't forget, there's an invisible 1 here. There's always a 1 in front of our square root. If you ever forget, just know, you just know that it's going to be what? You just know that it's going to be like behaving like a variable, okay? So it's going to be 7 root 7. All right, and that's our solution. All right, let's try one more. Actually, let's go on to part 2. Please ask me if you have any questions, okay? Let's go to part 2. How do you multiply? How do you multiply binomials and the significance of conjugates? We're almost done. What's the difference? We'll see, okay? So we're going to try these 2 examples here. All right, so we have these 2. Root 3 plus root 5 squared versus 4 minus 2 root 3 times 4 plus root 2 root 3. All right, this is just like this, right? We've done this in algebra so many times. A plus b squared, which is a plus b times a plus b. Isn't this guy sort of like, yes, I heard you say it, a plus b times a minus b, okay? Which becomes a squared minus b squared. Couple basic things that we should know, okay? So let's actually try these. So if you do root 3 plus root 5 times root 3 plus root 5, you should multiply, distribute all of these to each of these terms. So you get root 3 times root 3, which is 3, right? What's root 3 times root 5? It's going to be root 15. How about here? Root 3 times root 15, root 5 is root 15. And this guy, root 5 times root 5 is just going to be 5. And then you combine it like in terms, 8 plus 2, root 15. Notice the 2, be careful, and that should have been your answer here. Now, 4 minus 2 root 3, 4 plus 2 root 3, it's just a squared minus b squared. So if you want to actually multiply it out, I'll do that, okay? So it's 16 plus 8 root 3 minus 8 root 3 minus 4 times 3, because root 3 times root 3, right? So I got 16, this is 0, minus 12, because this is 12, which is 4. That should have been your answer there, okay? Make sure you understand that. Slow it down. Stop the video if you have to, okay? All right, we're going to move on. Slow it down or finish the video, stop the video if you're done. We're almost done. We got a few more examples. All right, so now let's try this, part 3. So now, fill in the blanks here. Using the what? How would you rationalize this? Yes, I know what you were thinking. Conjugates, okay, using conjugates. So remember, you guys, conjugate of a plus b is become a minus b, becomes, right? And you remember a long time ago we did complex numbers, a plus bi, it's a minus bi, right? So just come and remember those, okay? Same thing with conjugates for radicals. What's a conjugate of 3 root 3 minus 2? You got it. It's 3 root 3 plus 2. 3 root 3 plus 2. The A stays the same, the B changes, okay? So you guys, let's multiply this out. Remember, our goal is to get rid of this radical here. We don't want this radical. And that's how we're going to actually rationalize. So let's multiply this out. You get 4 times 3 root 3, which is 12 root 3, with 4 times 2. It's 8. Denominator now. 3 root 3, isn't this a plus bi times a minus bi, which is a squared minus bi? Okay, so let's try this. What's 3 times 3? It's 9 times root 3 times root 3. So it's 9 times 3, so it's 227, right? And we don't need to multiply the middle terms because they drop out, right? Positive and a negative, gone. So it's minus 4. So we're almost done. 12 root 3 plus 8 all over 23 should have been your answer. No radicals, all right? That's how we rationalize. Now, part 3 is just a harder simplification. Just make sure, they're all same indices, but we should actually simplify these guys, right? Now we're thinking index is cubed, so think perfect cubes, okay? All right, let's do this. So now, 3 cubed, now it's 8 times 2, right? Because 2 to the cube is 8, right? Okay, minus 4 cubic, how about 54? You got it, 27 times 2, because 3 cubed is 227. I'll never give you a huge number that you have to work with. 128, well, the next one is this. So, 4 cubed is 64, right? Okay, you're right. I always try to give you ones that actually work out pretty well, okay? Now, these are all perfect cubes. Let's pull those out. 3 times cubic root of 8 is 2, so it's 6 cubic root of 2. 27, cubic root of 27 is 3, so it's 12 cubic root of 2. How about here, lastly, 4 cubic root of 2. Now we know, oh, they're all square root of 2 and index is 3. So we can combine these guys. 6 minus 12 is negative 6 plus 4 is negative 2 cubic root of 2. Alright guys, good luck! Bye! Good luck!